Okay, so for the next section, we're trying to find the equation of a line given with the following information. Put the equation in slope-intercept form if you can, and then use the information. So the first problem is requesting an equation of a line passing through 2 points. So my game plan is first we need to find the slope, and second we need to use the slope that we found in the first step and one of the points, and we're going to use those two things to get an equation. That's the game plan. Now, in order to find the slope from 2 points, I need to use the slope formula. So I'm going to label my 2 points x1, y1, x2, y2. And the slope formula is the change in y, which means y2 minus y1, over the change in x, which is x2 minus x1. So that's 7 minus 1 over negative 4 minus 5. In the top I'm getting 6, and the bottom I'm getting negative 9. So that reduces to negative 2/3. I can divide the top and the bottom both by 3 to get negative 2/3. Now I did all of that so that I could use that slope negative 2/3 and one of the points. Well, which point do you want to use? It doesn't really matter to me. Whichever point you like better. Often students like the ones that doesn't have any negatives, which is fine. I don't really care. So I'm going to use 5, 1. So then I'm going to use the point slope form. Because I have a point and a slope, I want to use point slope form, which is y minus y1 equals m parentheses x minus x1. So we have y minus, because there's a minus in the formula, y1, which happens to be a positive 1. So the minus is from the formula. Even though the green 1 is positive, it's still minus. Equals m, and my m, that was the negative 2/3 that we found in red, parentheses x minus x1. Well, the x1 that we found from the point is 5. So this is the equation, but the question said put it in slope-intercept form. This is the equation, but not in slope-intercept form. So I'm going to distribute and clean this up a little bit, which gets me negative 2/3 x. Negative 2/3 times negative 5. If you want to do that work off to the side of your paper, multiply the tops, I'm getting positive 10. Multiply the bottoms, you're getting positive 3. So that's positive 10/3. And then I need to add 1 to both sides. So let's see here. If I add 1 here, I'm going to have to add 1 here. And then my equation is going to be y equals negative 2/3 x plus whatever 10/3 plus 1 is. Well, 10/3 plus 1 doesn't have a common denominator. So in order to get a common denominator of 3, I'm going to have to multiply the 1 by 3 over 3. So now that's 10/3 plus 3/3, which is a total of 13/3. Now I can put that in my answer, and now this is the equation of the line that passes through the 2 points that were given and is in slope-intercept form. Our next problem says find the equation of a line that's perpendicular to 3x plus 2y equals 6 and passes through this point. Okay, so we have basically the same game plan. First I need to find the slope, and then step 2 would be use that slope that I just found and the point from the equation, from the problem, to get the equation. Now, finding the slope is not going to be the same as it was in number 12 because it didn't give me 2 points, so I can't use the slope formula. But I can use the equation of the perpendicular line. So this is perpendicular, so I'm going to try to find the slope of this line by moving the 3x to the other side. I want to solve for y. If you move it to the other side using transposition, you just pick it up and move it to the other side. It changes signs. If you don't like that, you can always just subtract 3x from both sides and you'll still get the same answer in the same amount of steps. Now we're going to divide everything by 2 to get y is equal to negative 3/2 x plus 3. So the slope of this line is negative 3/2. But that's not the slope I want. I want the slope perpendicular to it. So perpendicular is opposite and reciprocal, meaning your signs change from negative to positive, so my perpendicular slope is going to be positive, and then the reciprocal of 3/2 is 2/3. So 2/3 is the slope that I want to use in step 2. I have the point that we haven't used yet. That's going to be my x1, y1. And then the formula says y minus y1 equals m parentheses x minus x1. Now this step 2 is the same as the step 2 in number 12. It's exactly the same. You have the same information. You have an x1, y1. You have a slope. Now you have to just plug it in. So we have y minus a negative 2. The blue minus is because there's a minus in the formula. The green negative is because there's a negative on the green 2 in the point. Equals m, and in this case my m is positive 2/3 because it's the opposite and reciprocal. Parentheses x minus x1, which is 6. So that's 2/3 x minus, let's see, 2/3 times negative 6 over 1. Multiply your tops is negative 12, multiply your bottoms is negative 3. So that's a negative 4. Minus a negative, that's really add 2. So when I subtract 2 from both sides, I'm getting y is equal to 2/3 x. Negative 2 minus 4 is negative 6. And that is my equation of the line that is perpendicular to 3x plus 2y equals 6 and passes through the point 6 comma negative 2. In this next section, we're trying to use transformations of basic functions to sketch the graph of each. There's 5 of these on this review because I wanted to make sure you reviewed all of your basic shapes, but I don't think there are going to be 5 on the final exam. So, but just know that you need to know all 5 basic shapes. So the first one is a cubic. The cubic shape, if you'll remember, is like that S shape, the elongated S shape. The horizontal shift, that's inside the parentheses, opposite of what it looks like, so it's going to be negative 4. The vertical shift, that's outside the parentheses being added or subtracted. You don't change the sign on that one, so my vertex is going to be negative 4 comma negative 5. And then we have a compress and stretch. The compress and stretch is the number that's out in front, and in this case there is no number in front, so there's an invisible times 1. So that's going to be a times by 1. Now going back to the basic shape, we have a vertex and we have 2 critical values, right? Normally to get to the critical values we go right one and up one, left one and down one. And because my compress and stretch is 1, it's going to stay the same. I'm not stretching higher or compressing any lower than normal. So I'm going to go to negative 4 comma negative 5 and put a dot. That is my vertex. To get my critical values from my vertex, I'm going to travel right one and up one and left one and down one. Now just having those 3 points correct is very important, but you also now need to do the shape correctly. So the shape is this S shape, and then that's it. Now some students have a hard time drawing that S shape, so if you have a hard time drawing it, rotate your paper 90 degrees and then just kind of do like a parabola, a half a parabola from your red vertex and then up, and then rotate your paper in the other direction so that you can do another up half parabola, and then that's kind of a cheating way to do it, but it works and it looks appropriate. So that is how your graph should look on number 14. So number 15, because it's got a squared up here, that tells me it's a quadratic or U shape. For the U shape, I have a vertex and I go right one and up one normally, and left one and up one. Now we might have to change that depending on our compress and stretch, but for now that's what it is. The horizontal stretch, that's opposite of whatever's being added inside the parentheses, so that's negative 5. The vertical shift, that's whatever's being added or subtracted outside. so that's negative 2. And my vertex is going to be negative 5 comma negative 2. And the compress and stretch is the number that's out here in front. That's my A. So that's 3. Now because the A is, or the compress and stretch is something other than 1, that means instead of going right 1 and up 1, I'm going to go right 1 and up 3. Notice that the left and right didn't change. It's only the vertical that changed to become the A. So I'm going to go to my vertex at negative 5 comma negative 2. Okay, and then to get my other points, I'm going to go right 1 and up 1, 2, 3 because of the A, and left 1 and up 1, 2, 3, which makes my parabola a little bit more slender or narrow. Technically I don't like the word narrow. It's really that we're stretched longer, but it looks like it's more narrow. On our next problem we have cube. A cube, that's one of those like stretched out end shapes. Let me do that a little bit better. There we go. Okay, so which has a vertex? We go right 1 and up 1 to get to the next critical point, and left 1 and down 1. Okay, and we might have to stretch or compress that later, but for now we'll just leave it as that. My horizontal shift, that's whatever's on the inside of the parentheses being added or subtracted, opposite of what you think. So it looks like minus 4, so it's really positive 4. There's nothing being added out here. So if there's nothing being added for a vertical or horizontal shift, it's going to be a 0. Alright, so I put 4 comma 0 as my vertex, and then my compress and stretch is the number that's out in front. In this case, the number that's out in front is the 1/2. That's the thing that's being multiplied to the parentheses. So I'm going to go to 4 comma 1, and then I need to go, because we have a half here, that means all of my vertical stretches and compresses, instead of going right 1 and up a whole, I'm only going to go up a half. And instead of left 1 and down 1, I'm going to go left 1 and down a half. Okay? So I go right 1 and up a half, and then I go left 1 and down a half. And because you got only down and up a half, what happens is it makes my end shape a little bit wider. It's really compressed, but it looks more wide than what it would normally have looked like. So that is the solution to number 16. Again, if you need to, if you can't do that all in one step, I'm not sure if you noticed, I just did like half a parabola here, and then if you turn your paper upside down, then just do half a parabola there. A lot of students have a hard time doing that correct shape on one swoop, so instead just do half of it and then turn the paper around, do another half, and then that should help you draw it so it's not so crazy looking. On number 17 we have absolute value. Absolute value is a V shape. To get my critical values from my vertex, I would be going right 1 and up 1, left 1 and up 1 to get my other two critical values. That is until we have a stretch or compress. So my horizontal shift, that's inside the parentheses, opposite of what you think, so it's a positive 6. My vertical shift is up and down, that's the thing being added outside. That's exactly what you'd think it was. Don't change your sign on the vertical. So I have 6 comma 4 as my vertex. And then my compress and stretch is whatever's in front being multiplied to the function. So that's a negative 3. Now that negative 3 is going to change my picture. So instead of going right 1 and up 1, I'm actually going to be going right 1 and down 3. Instead of left 1 and up 1 like I normally would have, I'm going left 1 and down 3. So take your vertex and plot that at 6 comma 4. And then to get your critical values, instead of going right 1 and up 1, I'm going right 1 and down 1, 2, 3. Instead of left 1 and up 1, I'm going to go left 1 and down 1, 2, 3. So those 3 points have to be correct. In addition to having those 3 points correct, you need to have the correct shape. So this is going to be a V shape. So some students, like, they'll just do these short stubby things. Don't do that, okay? That's kind of silly. If you have space, make your pic as long as you can on your picture, okay? Number 18, that's a square root method. So that's like one of these shapes. To get the critical value on this one, I go right one and up one. That is, unless I have a stretch or compress. On this problem, it says -1 underneath the radical, so my horizontal shift is +1, opposite of what it looks like. The vertical shift of whatever being added outside, so that's a +5. So my vertex is at 1, 5, and my stretch is -1. So technically that's a reflect because it's negative, but it's going to do the same thing that the other A's have done in all the other problems. Instead of going right one, up one, I'm going to change that vertical to -1. So notice that the horizontal 1 always stays 1. All I'm doing is changing my vertical stretch and vertical compress. So I'm changing the up and down. So in this case, my vertex is at 1, 5. And to get my next critical value, I'm going, instead of right one and up one, I'm going to go right one and down one, because that is my stretch and compress. Now the vertex is where it starts, so you need to start your graph at the red and then make your shape towards the green, and that's going to be one of those square root method shapes. Sometimes, and I don't know why, students will make it go further. They'll like start up here, and you're not allowed to do that. You can't have these points up there, okay? So just be a little bit careful when you're graphing them, that you're only graphing straight from the red towards the green and in the correct shape.